Every organization has its own processes and toolsets. The comprehensive APIs available for Synopsys tools enable virtually any configuration. What follows is just one possibility. For our DevSecOps engineer example, let's consider a microservice application deployed using containers. In this example, we've created an application, let's call it Insecure Bank, and defined a workflow with distinct build, or CI, and deployment, or CD, phases. Let's first trigger this build to see how it works without any AppSec tooling. Our CI environment is a Jenkins instance hosted in an OpenShift cluster. Due to the security defaults applied within OpenShift, containerizing our build processes gives us some significant benefits. Chief among them is that each build segment executes in its own ephemeral container instance, with the Jenkins worker nodes being managed directly through an integration within OpenShift. The net result is that each CI operation is always working on uncached data, with task-specific tooling and dependencies. In this case, our application is written using Java, which requires Maven, and deployed using OpenShift tooling. Once the application is built, it's packaged using OpenShift, and exposed as a service which can be tested in a staging environment. On the right side of the screen is the OpenShift console with its pod view open. Here we can see the individual containerized steps of the build and deployment running. On the left side, we can track the Jenkins nodes, with the bottom screen showing the current progress of the CI operation in the Blue Ocean console. In our application, the build process took 1 minute, 34 seconds. Once the app is built, we can interact with a staged instance. From an AppSec perspective, containerized applications require 4 distinct areas of focus. First, custom code is created following common practices for the chosen platform and language. Second, open source components are packaged as required for the platform and language. Third, the container base image should meet corporate standards for hardened deployments. And fourth is a secured Kubernetes instance, where replicas of the container image will be deployed. Each of these areas has the potential to expose unique security weaknesses in the application. They each require specialized knowledge, and by extension, the security context workflows required to address them will also be specialized. It's important that the integration of AppSec tooling and existing well-defined build and CI processes not disrupt existing workflows. Given that detailed security assessments take time, our Insecure Bank development team has decided to place all CI-centric security testing into a nightly build. Last night's test run took just over 12 minutes to complete, but let's trigger a fresh build to see it live. While this is running, let's look at the build process and how the Synopsys tooling is integrated. The original CI process we saw earlier is broken into 2 phases, with the actual build occurring in a distinct phase. That build process consists solely of pulling code, building it, and storing the artifacts for later when we create the application from these artifacts and then publish it in OpenShift. The updated CI process with Synopsys tooling in place looks very similar. First off, we see that enabling Seeker on the application in CI occurs after it has been published. This ensures that the built app is the exact same as the app under test. Second, we see that the build was modified to perform a black duck analysis of both the source code and the base image, as well as a coverity analysis of the source code. These operations occur in parallel because the coverity and black duck scans can take some time. The bulk of the work is done server-side to lessen the impact on the CI process. Performing these operations in parallel also allows DevOps teams to use the Black Duck and Polaris APIs to determine the context when they wish to perform more detailed work. Looking at the actual modifications to the Jenkins files, we see that enabling Seeker in the CI workflow is simply a case of mapping a volume into the deployment configuration for the application container image and setting a couple of environment variables. Because these are configuration changes, the OpenShift deployment configuration will automatically redeploy the container instance with the updated configuration once these configurations are applied. This Kubernetes attribute allows you to adopt Seeker for containerized applications with minimal disruption to your AppSec initiative. Enabling coverity with Polaris is equally simple, using the Polaris CLI to invoke the static analysis. Performing a black duck analysis on the source code is also straightforward, and a black duck analysis of the base image for the container requires only that the image be determined and downloaded into the Jenkins worker node for analysis. Of course, the decision of whether to remediate issues or potentially halt a build because of policy changes depends on your organization. Organizations with a low risk tolerance might want to address all AppSec issues before shipping a new release by breaking the build, while others will prefer to create alerts for the team. Synopsys solutions support both. You can fail a build based on static or software composition analysis results by using the return codes from Coverity or Black Duck. But since Seeker IAST by definition operates in an interactive manner, failing a CI effort based on Seeker testing occurs after the usual functional test suites have run. Organizations wishing to adopt a no new security issues model will want to look at the defect tracking integrations in Synopsys products and use the release gate, or burndown analysis, in the defect management system as a trigger for a failed build. Let's check in with our CI process with full detailed SCA tooling enabled. It looks like it's still running, so let's dig into what it's working on for a minute and see how much more work we have left. The build is still in progress, the Black Duck source scan is complete, and the Coverity analysis and Black Duck image scan are continuing in parallel. Now that the static analysis has completed, we can create the image, publish the application, and enable Seeker on this app. In our Insecure Bank security run, the entire process took just under 11 minutes to complete. That process performed a SAST scan of the source code using Coverity on Polaris, an SCA scan of the source code using Black Duck, an SCA scan of the container base image using Black Duck, and enabled Seeker on the containerized app for IAST testing.